This meeting is being recorded.
This next section from Chapter 2, Section 3, identifies or introduces us rather to how to identify functional groups. So the term functional group is given to a certain arrangement, a certain pattern of atoms bonded to other atoms. For example, we may have seen OH, right, bonded to each other and then bonded to a carbon. So this would be what's called an alcohol functional group, for example. So we're going to learn a few different functional groups. There's some tables that introduce these bonding patterns, and we're going to review how each of these functional groups reacts in different ways. So down below here, we have the condensed formula first for this reaction, right? So we have this carbon here, is this carbon here, bonded to two methyl groups. Then we have this carbon here is the start of this double bond. This carbon here is the other side. And then even this carbon here has those two methyl groups, 1, 2. So we can see both the condensed and the bond line structures for the same reaction below. So a lot of times the bond line structures will make it a little more obvious, a little easier to see what functional group transformation is happening. Now, we use this term transformation because we go from this double bond here, that's a functional group, to the single bond here, which would be a different type of group. It's not really a functional group. It's called just an alkane when we have all single bonds. But this double bond here of an alkene would be considered a functional group. So we have this transformation. We go from double bond to single bond. This specific reaction is called a metal catalyzed hydrogenation. We'll get to that in Orgo 2. But for now, we just want to see the difference between our reactant and our product. So these atom arrangements, these patterns, depending on what they are, they give a rise to different functional groups. And it will make your life a lot easier if you memorize these. So we'll take a look here at table 2.1 and what they're talking about. It is given in your textbook as table 2.1. So we have one of the simplest compounds that we'll look at first here, something called an alkyl halide. So the alkyl portion is this R here. And any type of alkyl group is just a series of carbons and hydrogens, right, in whatever pattern. So whatever hydrocarbons you have, we'll call these alkyl groups. So these R groups are representative of these alkyl groups. So an alkyl halide, in this case, the R group is this here. So we have 1, 2, 3, or a propyl group, and we have a chlorine atom here. So this would be called, this alkyl halide specifically would be an propyl chloride. And if we wanted just to represent an alkyl halide in general, we use the R to represent the hydrocarbon portion, and then the X represents one of these halogens here. So X is just a general way to represent a bond to a chlorine, bromine, or iodine. We won't really see fluorine too much. So our next functional group, notice that alkane is not listed, but alkene is. So when we have a double bond, this would be specifically 1-butene because the double bond starts at carbon 1. So if we worked backwards, we would see 1, 2, 3, 4 carbons in our butene. And since it has a double bond, right, we end with that ENE ending. Down here, we have butyne. So this is an alkyne here. And this R group would be a hydrogen, right? And then this R group over here is this portion here. So it's 1-butyne because between the carbon 1 and 2 is where the triple bond starts. So definitely review all of these functional groups, review how they're oriented, the names. So this is the general structure over here of a ketone. We'll look at ketones if you take Orgo 2 in chapter 19. But we need to know this carbonyl, this central carbon bonded to an oxygen, is key with a ketone. The only difference between a ketone and an aldehyde is that an aldehyde has that H, has a hydrogen on one side where the R group is, and a ketone would have two CH groups, whatever they are. We'll have to learn carboxylic acid. So this is the portion here that makes it a carboxylic acid, right? The R group isn't part of the functional group. We have acyl halides. These are less commonly discussed. And then we have an anhydride functional group. I skipped over alcohol because I had discussed that before, and we saw some ethers earlier. We saw methyl ethyl ether, etc. Right? So an ether it's similar to our alcohol in the sense that it has an R group bonded to a central oxygen, but in an alcohol, the other R group is an H, and then here we have another hydrocarbon. So there's some more functional groups listed here. We have things like thiols, sulfides, and aromatics. So these are also called arenes. And benzene, this structure here, is the basis for all aromatics. Then we have an ester functional group over here. So it's really the carbonyl that's bonded to an oxygen. It does not depend on what these R groups are. So this again is the ester portion of our ethyl acetate. Then we have amides, which are a carbonyl that are bonded to a nitrogen on one side instead of two carbons. And then we have an amine here. So just the fact that there's a nitrogen, it stems from ammonia. So we have three groups. They could be two hydrogens and one hydrocarbon, two hydrocarbons and one hydrogen, or as you see here, we could have three R groups, all hydrogen, or hydrocarbons. Every variation except for three hydrogens, because that would be ammonia. So what we have here are two ethyl groups. So this would be called diethylamine, specifically for this amine. So again, know the functional groups, know the atom bonding patterns, and you'll be very successful this semester if you understand that. All right, so that's where we'll wrap up section 3. We'll continue with section 4 in the next video.